Hi, recording is rolling. It is Monday, August 12th, so the first day of school. All right, so yeah, hope you guys are having a good day, had a good summer. One thing I really like about this academic schedule is we get a good solid couple months off. All of us can unwind and find other things that are interesting, maybe travel a little, see family, and then we get to come back and have a more structured environment. And yeah, now we're back in school and everybody gets hit a restart. And I'm actually excited to be back. Summer was awesome, and I think it's going to be a great year. All right, so I've got three different type classes. I'm probably going to use this video for all my classes. This presentation's not too much different from class, right? But you guys in front of me are physics honors. So you guys see this code right here? It says Google Classroom code, right? Go ahead, write that down. It's also printed on one of the materials I gave you guys. Gave you guys a syllabus curriculum when you guys walked in. It's also printed there, right? My other classes have different codes. My AP class also has an AP classroom code, right? And your guys' homework today is just very simply just log on to or join the class using that code. Pertains to your class, of course, and go and explore some of the materials on there. Later in this presentation, I'll show you some of the stuff that I've already posted there, just so you can get an idea of what's in this class. Right. So this video that I'm recording right now, I will post to Google Classroom after school today, so you guys will have access to that too. Okay. Ooh, this one's fun. Perseid meteor shower usually kicks off the school year. The main night for that was actually not last night, although it's pretty cloudy. I don't know if you can see the anyway. But if it happens to be clear tonight, take a peek at the sky, you might see a couple shooting stars. All right, so you guys got any questions so far? All right. All right, so, okay, so like I just said, you guys' homework tonight, just join the class on Google Classroom, check out some of the materials. All right, and yeah, we've got a bunch of stuff kickstart class today. So here we go. Name cards. There's a name card in the top left corner of your desk. Right, so you guys in front of me happen to be period 7. You guys write your name next to the 7 if you haven't done that yet. The other classes too. All right, I am going to make some seating charts tonight, and then I'll be able to do attendance real fast so that starting tomorrow, we'll be bam, you're gonna go knock out attendance and go right into all the physics stuff that we got to do. Every year I try out some new ideas. Something that I want to try out this year, so you guys know, head for this is, I think probably every couple weeks or so, I want to come up with a new seating chart, and then how do you guys switch around? So you guys get to meet other people, work with people that think a little bit differently. By the end of the semester, end of the year, you'll know a lot more students in the class. So we'll see how it goes. Haven't done that yet, but check. But wherever you're sitting right now today, probably you're gonna be sitting probably the next couple weeks, I think. So see that. Do some school rules. All right, tardies. Good to force me to school on time and class on time. We're really starting enforcement of tardies next Monday, I think. Next Monday. Okay. So if you're on time, awesome, you're doing it right. If you're late to class, I'm just gonna mark tardy in attendance, and then administration knows after they see so many. If you're collecting a bunch of tardies, especially over a bunch of classes, then they'll give you detention, carrots and sticks. There's kind of the stick side of that. Help incentivize you to get to class on time. I know every year's a little different. I know Vera is growing, we get more traffic. Maybe whatever time you left school last year, maybe you have to leave a little earlier, possibly this year for that reason. Something, but then you have a few days to figure that out. This class I use every minute of class for something, right? I really want to get the best use of your time in here. So if we have a 48-minute class, I'm going to use all 48 minutes. A lot of times it's something interactive on your side. Sometimes you guys be doing some labs or something like that. So when the bell rings, I'm going to do attendance real fast, and then bam, then we're right into the lesson. Yeah. So if I got students like wandering in like 30 seconds late or something, it really like disrupts the flow, and got to pause everything and open the door, and then kind of takes away from class time for everybody. All right. So make sure you get to school on time. If you're regularly getting to school like 2 minutes later or something, if it just happens to be like first period, step back and think about that. Okay, well, is there something systematic about this? Right? Okay, maybe last year everything's working, but maybe this year it isn't. Hey, maybe I have to get out the door 5 or 10 minutes earlier than I would. Maybe I have to set my alarm clock a little bit earlier. Right? And there could be a systematic fix to that, right? Right. Dress code. So I think I sent out a more detailed dress code list. Some email you guys probably got recently. But our main things we're looking for is no midriff showing, no crazy short shorts, things like that. Runs around the room. I think you guys are pretty good here. Come to school, dress school appropriate, ready to go. Then there's more professional environment. Makes it a little bit easier for everybody to learn. Right, so all good there. Right, cell phones. Of course, probably most of all you guys have cell phone. Let's make a habit to just keep that out of sight, out of mind. Whether it's in your pocket or your backpack's all right. Of course, tomorrow you guys are getting laptops, and then any digital stuff you have to do just be on a laptop, right? But yeah, if you just take that option off the table of even having the availability to pull it out, right? So if you're sitting in a classroom and say, okay, I'm just going to fully focus on what we're doing in this class, then after a while you can train your brain to just fully focus and whatever class you're in and get the most out of that class, right? Versus it, if it's even an option on the table of like, I could pull it out of my pocket, I could check my text, I could see who posted what, right? Now it just takes up space in your brain, right? Which is not helpful to you or really anyone else, right? Because if you pull out your phone, everybody else is seeing you do it, they're thinking about their phones, but really, like I said a minute ago, I want to give you guys full opportunity in this class to make use of every minute, and boys got cool stuff to tell you guys. Okay. All right, bell schedule. All right, so that slide right there, you guys see these printouts right here. It's the same thing. So bell schedule. And figure out where you're switching classes. There you go. Probably a lot of you guys were here last year, last couple of years. Some of you guys might be new. Got a lot of students moving in and out of state. If you are, welcome to Florida. Good place to be. Right, so this Monday through Thursday is the same thing as it was the last couple of years. Right, so no changes there. But Friday is a little bit different. I don't know if you guys have noticed yet, but here you go. Or maybe you have. Do you guys notice there's only 4 minutes between classes on Friday? You guys see that? 4 minutes, right? So yeah, have to move a little bit quicker between classes on Friday. Don't know how it's going to work out. Haven't done that yet, but gonna find out in a few days. So there you go. Of course, you got the paper print there. All right, laptops. Tomorrow's going to be laptop day. So period 1, you get your laptop, and then every class period after that, we're going to show you some videos. You guys will take little paper quizzes, that sort of thing. All right, more on laptops. This one-to-one agreement paper, you probably picked that up during registration. I think most of you guys did. If you have not got that paper yet for whatever reason, you guys see the stack of papers right here. This is that one-to-one agreement. If you need one, if you haven't got one yet, then go on during registration. Okay. Some of you guys, I think, did pick up one during registration, but you need a parent signature, so your parent may not have been there. I've had a lot of students turn that paper into me today, and I just took a whole set to the office. You guys see this gray tray right here? Gray tray, right? Anything you turn this gray tray, I'll get. Yeah, about an hour ago, I had this thing was full of those papers, so I just took those down to the office. So there you go. Oh, I also posted this to that Google Classroom page I was telling you guys about. So if you want to print that out, you can do there. Friday, we have a pep rally period 7. So yeah, try to figure out how I can make the best use of everybody's time, and knowing that not going to so much have a 7th period. So all right, we'll do what we can do. All right. Okay. Right. Oh yeah, there's this video 4th period. It's like 2 minutes. I might post that to Classroom if I remember that. Okay, laptop day tomorrow. I might possibly have about 10 minutes of each class tomorrow to see if I can do something with that. There's a grade level presentation on Wednesday, and then Friday, there you go, pep rally 7. Boom, boom, boom. Things come up. Right. Make the best of our time. Okay. All right, passes. All right, so I think we got to try to stick to the system we had last year. I think it was pretty good what they had. So you guys see some passes hanging right here, passes. Right? At some point you need to pass, go somewhere. Just let me know real fast. This red one is to guidance or the front office. I've got a pink one here that's to the media center. By the way, start to lock the media center door. I think it's like a new law or something like that. So you have to lock the door. Don't look for that. Okay. This green pass right here, this is restroom pass. It says on restroom pass. Okay. So again, like more often than not, I'm probably like recording up here, have in the flow, explaining something physics, right? So if you have to go at some point, just look up here, grab this pass, give you a thumbs up, and you're good to go. Right? Of course, bring it back pretty fast because you've got one student out at a time, right? So yeah, so if you're out of the restroom, there might be another student waiting for you to get back. So just keep that in mind, right? Get back as soon as you can, right? And then, oh yeah, this rule too. So no passes first 10 minutes or last 10 minutes of class. I think it's trying to keep a bit more order in the school, right? Because we got like, somebody's getting to pass like the first minute into class. It's like, okay, well now they don't know, is that student party to a class, or wait, what's going on there? And kind of same thing like last minute of class. If it's like there's like 2 minutes till the bell, and there's a bunch of people walking the hall. It's like, wait a minute, are they getting to class early? What the heck is going on? So okay, so we're gonna try to stick to this as best we can. Okay. Drills. Ooh, all right. So fire alarm rings. Question: what are you guys gonna do? Yeah, yeah, just like you're doing. Just sit there and wait for further instruction. I think everybody just got that right. Yeah, stay in place, wait for further instruction. Right, and then someone will come over the intercom and they're going to tell us probably one of three things. So let's look at three main types of drills. Right, shelter in place. That means no hall passes, right? No hall passes, right? So if you happen to be out in the restroom, just get back really fast. Normally they call us one if there's a bunch of lightning in the area, right? And they might hold class so we don't switch. All right, okay. So we're gonna stay in here if we can. Now we can keep doing what we're doing. If you guys got labs or something going on, just keep doing what you're doing, but try to stay in this room. Lockdown. Ooh, guys, if they call lockdown, where do you think we're going? Right, back of the room, you guys think? Oh, maybe a hard corner, right, where no one can see from this window in the store right here. Right, you guys think? Right, so we're looking to have these lab tables. They call lockdown. We're going back behind those lab tables and I'm going to turn the lights off. And of course, we're all going to be really quiet, right? Really quiet. Because we're running a drill as if something serious was going on. There's someone around in the hall. We want them to, like, if they looked in the window, to think that there's nobody in here, right? Okay, lights are off. I don't see anyone. I don't hear anyone. Right, so that's our thing. Right? All right, and then the third main type of drill is fire drill evacuation. So this one's a little new from last year. We still got a plan A and a plan B. Let's look at this. All right, so here's the school from above. Here's the building we're in, building 3. You guys see that? In fact, where my mouse cursor is right there. That's about where this room is. Right, you guys got that? Right. Now, they send us outside on a fire drill. Whether they send us to site A or site B, it starts out the same way. You're gonna go to a store, you're gonna hang left. You guys know there's a fire escape door all the way down at the end of the hall there. Right, so that'll start us out. You know, if they send us to site A, this year, that's going to be this big old practice field. I see practice field. I've got a slide after this one to show more detail, but okay, so site A somewhere over here. Right, site B is going to be this football field. I think they want us on the bleachers this year is what they're going to do. Right, so football field, bleachers. Right, let's look more detailed there. So here's a different perspective. Here's building 3. We're about right there. That's where we are. So here's evacuation site A. Yeah, leave this room, hang a left all the way down. Fire door. Now we're outside. Go down the stairs. Right, and then I don't know if you guys can read this. It's like size 2 font. It says number 1 through 80. Okay, number 1 through 80. Our class is number 51. 51. It's kind of the halfway point-ish. Right, number 51 out of 80. Okay. You guys see this right here? The signpost. Got Griffin on a stick. Everybody see Griffin on a stick? Griffin on a stick. So when there's 2,000 people out there, oh, hey, there's Griffin on a stick. And you can go find us and we'll all be together and we'll all be good and not on fire. If they send us to site B, here's the main football field. We're coming in from this point of view, right? From that direction, right? Here's the home bleachers. Now, in front of the home bleachers on the fence, there's placards marking A through I. Right? So A through I, different sections. And our class is supposed to be section D, section D. So if they have us go up in the bleachers, we'll be in section D. I know last year they had us on the field itself. So if they do a little switcheroo and have us on the field, then we're going to also line up in front of section D. So section D, right? So if they send us outside, I will jot that down real fast, throw it on the projection, and then everybody should know where we are. And just have my sign, and here we go. Okay. Questions so far? You guys good? Everybody right? All right. All right. Now more fun stuff. Fun stuff. I think God has all the rules and procedures for the most part. Right? So, got this graphic, got a bunch of little boxes. Do you guys see how many boxes across? 52. 52. Ooh, guys, if there's 52 boxes across, what do you think each box probably represents? 1 week. 1 week. Right. Oh, so each row could be a year, right? 52 weeks in a year. And how many rows down? About what, 80, 90, something like that? Hey, that's a roadmap of our entire lives. Every Saturday, check off a box. You check off all the boxes, it's game over. And you guys are probably in about this yellow band. I think most of you guys are starting 11th grade. That's about the middle of this yellow bandish, something like that, right? And so all your life leading up to that point, brought you to this room, and there's some adventure that awaits you after that. And well, probably a lot of you guys are figuring out what that's going to be, what that kind of looks like. Hopefully you guys are figuring out your interests and figuring out what you're going to do after high school. Asked a lot of students that question, what do you do after high school? Get answers anywhere from, dude, I have no idea. So, oh yeah, I never know kind of exactly what I want to do. I want to do this program, get this job, right? Or maybe you're somewhere in the middle, all right? figuring that out. Here's maybe one framework for figuring out what do you want to do with your life, right? So got a short life, but let's make the most of it, right? So going around the periphery here, what do you love doing? What do you enjoy doing? You have a certain interests. Hey, what can you be good at? Maybe what skills do you have? Hopefully there's some overlap there between what you enjoy and what skills, right? And hey, you guys are young enough, have enough brain plasticity. Maybe you can build some new skills, right? While you're in school to learn things, but maybe outside of school too. Maybe there are certain interests, hobbies you want to pick up, skills you want to have that are not necessarily in your classes. Right? I just got time for that. Okay. These two, what can be paid for? What does the world need? Sort of go hand in hand. Like, what's the demand for some labor market? What you could do. Right? Yeah, and I have this question here: how does physics connect? But really, any of your classes, say, I wonder how this could possibly connect to something possibly down the road. It's kind of hard to tell looking forward in time, but a few years down the road, you might look back and be kind of surprised. You might be surprised. I've been surprised plenty of times of things I just learned or was interested in some class I took, and okay, I don't know what I'm going to use this for, but years later I do. So whoa, I didn't know I was going to pick up like this skill or this thing, and it's really handy later on. Okay. Is it possible that you'll work a job that doesn't even exist yet? Right? The world's just changing so fast. Technology's changing so fast. So a crazy example is back when I was in your guys' shoes, back in high school myself, YouTube did not even exist. Right? And now a lot of people make careers just posting YouTube videos. I know just the last couple of years, AI has been big. Right? So some people spend like 20, 30 years building some skill, and now just press the button and AI can do it. So maybe navigating that could be a job on it. I don't know, kind of hard to tell what the future is going to look like, what society is going to look like 10, 20 years from now. But be open to everything, get as much as you can out of each class, and in this class too. Might be surprised what ends up being relevant down the road. Right? Ooh, habits. So habits, hard to break. Right? You get some routine. It's kind of what habit is, right? So there's some neural connection in your mind, right? You get some environment. Oh, I'm in this classroom or I'm at home, and right, your brain goes into some mode, and now I start doing X, Y, or Z, right? August is a fantastic time. Like right now, this is the best time to establish new habits, new routine. I mean, you kind of have to, right? You've got a whole new school schedule, right? So think about what kind of student were you last year? What kind of student do you want to be? I've had plenty of students either right before the school year starts or right around the first couple of days of school say, "Oh man, this class looks so cool. I've heard all kinds of cool things about it. These labs look cool, or physics looks fun. I want to learn this. Maybe even I want to go into a career field that's definitely going to involve physics about every day, like some kind of engineering field. But I just don't know if I have the discipline as a student to take this class because I know it'll be challenging. It's probably going to be a good amount of work. I don't know if right? But maybe that's based on being a student in the past. So think about what kind of student you were in the past and whether you want to follow that or not, right? So think about how last year went. So if you were on top of all your studies and doing really good at school and got everything in order, keep doing what you're doing if it's working. On the other hand, if you think, man, I kind of got into trouble maybe at the end there, and I was a little bit disorganized. I was starting to miss assignments, and everything was kind of falling apart, and that wasn't fun, and I was stressed and behind on everything. Then you kind of sit back and say, okay, well, how can I systematically fix this? How can I maybe take the next few weeks to establish routines that now can build a good habit? There's some science behind this, where it takes some number of weeks to make a concerted effort, and then after a while, your brain just goes into that mode. So if you build yourself a habit of, okay, I'm going to go home every day. I've been using my planner. Thanks, but set my next bullet here. Use a planner. Got more to say on that, but been using this planner. I'm going to open up this planner. I got these 5 things I got to do, and bam, 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 bam. Maybe I'll take a break at some point. Eat dinner, watch a couple of YouTube videos, and then I'm going to open this planner and just knock all these assignments out. And then I've got a little time left over, and now I can do some other things I wanted to do too. It's play a game or study something else you want to study, some personal hobby, something like that, right? Oh, yeah, I know. I mean, I could definitely say that for myself. I've been using a planner, probably since middle school myself. Oh yeah, great. So I know I'm at school working hard every day. You guys are at school working hard every day, and throughout the day, it's like, okay, I got to get this ready for tomorrow. I got to design this page or set up this lab. Right? So I'll jot that down in a planner. they'll go home, sit down on the couch completely wiped out, exhausted, and oh man, I know I have stuff to do. I don't remember what it is. Open up the planner, and I got it all right there. Let's get eat. Let's bam, 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 like, knock it out. And then yeah, now they've been organized about it and able to knock everything out. Now I got a little time left over and do other fun stuff too. Framing. This is a good one. If you have a positive framing, just have a positive attitude about your classes. I'm saying physics there, but this could apply to your other classes too, right? And so, how do you feel when you walk into school or any class? Do you have the feeling like I have to do it? I'm going to be given an assignment. Or is it more like, oh man, this class is a challenge, but it could be fun. I know Mr. Griffin's going to give us all these challenging physics puzzles, and I can't wait to jump on this next puzzle and this next opportunity. And I know I'm going to learn something cool and take something away, and maybe this will be useful down the line, some memory, right? So yeah, and if you can be cognizant of that, be aware of that, now you have some kind of metacognitive process, some ability to have some kind of control over that. Yeah, if you can have a positive framing, you're sure it's definitely make life more enjoyable, right? You can have some kind of positive framing about that. All right. Recommended materials for this class. I'm gonna recommend you have some kind of calculator. It could be scientific, it could be graphing. I'm just gonna use this little scientific myself. It's about $15 at the store. This exact model, I know each of you has one on your desk, so put one in each desk, got one class set. So if you want to follow along exactly what I'm doing button for button, since we got the same model, you guys can do that. If you want to use your own calculator, that's okay too. If you've got a graphing or some other kind of calculator, just kind of more on you to figure out exactly how to navigate it. Every calculator is a little bit different. Okay, access this function with this button. Planner. I know they gave each one of you one of those planners at registration. And if you missed it somehow, then go to the office and get one of these. And definitely use it. Because if you've never used a planner before, just start trying it today. Just next few weeks, make a habit of using the planner, and you'll see how much more organized your life is, how much more effective it makes it, how much more enjoyable just the school routine can be. Just because you have everything in a nice, convenient list. Yeah, again, if you never used one in the past, you don't have to. I guess it's like that quote I had on the last slide. You're under no obligation to be the same person we were 5 minutes ago. Like how do any of us interface with the world? Like, okay, well, a lot of it's just inertia. What have I always done? What's my routine always been? Why do I have this or that opinion? Oh, well, I've just always thought that, right? But you can stand back from it and think, oh, hold on a minute. Why do I think that? Do I really think that? Do I want to think that? Do I? What kind of student have I been? What kind of student do I want to be? Hey, maybe I can use this planner and make things a lot easier. Something to keep notes in. Now, if you want to do a spiral notebook, if you want to do a 3-ring binder with loose leaf paper, you want to have your own system going on, something to keep notes in. Really highly recommended for some reasons. Right? So if you're writing things out, that for one, you're building neural connections in your mind, right? So you see me solve stuff, right? I know plenty of classes, right? I can like sit and watch the teacher like solve something, and I can watch step for step. Yeah, that makes sense. Yeah, that makes sense. And see them get to the answer. Oh yeah, that's a whole logical process. Right? And then somebody puts a blank paper in front of me, and if I've never written it down with my hand before, say, oh, I've seen this solve. I know what the answer is, how to get to it. And I put the pencil down on paper, say, oh, right, and then your brain freezes because it doesn't know how to do it. Right? It doesn't know how to transfer it on through the pencil. But if you're taking notes, then you're building the neural connections. And now you can go from start to finish, writing it down on paper because you've done it before while you're taking notes. There have been plenty of times where I've looked through my notes and I've written things that I didn't even remember writing. So sometimes you remember the teacher saying it. It's like, oh, wait, we were taught that. Well, I'm glad I wrote that down because now I see it. There will be lots of times where I'm going to be solving physics puzzles up here, and I might get halfway through it. And then I'll say, okay, let me see how you guys are doing. Who's going to beat me to the answer? Who can get to the answer before I do? I'll walk around, look at you guys' notebooks, see who can solve it before I get to the end. Because if you guys can solve it before I finish solving it, that's a good indication to both you and me that you know how to solve these things. AP, okay, so here I'll say this to you just in case that using this recording is AP students are going to recommend using Lab Notebook or keeping all their labs together so they can get college credit for the lab portion of it. Learning pyramid. Okay, so this slide, not 100% scientific. I don't think those numbers are, but there is a truism here. So talk about this. Yeah, it's this. The more active and engaged you are in your own learning process, the more you're going to get out of whatever you want to learn. Right? So the top 5% lecture. Okay, so if you just sit in a class and you just listen, which is okay today. Today's kind of just a sit and listen today. Right? But if you do that every day, then are you going to get something out of class? Maybe a little bit. I mean, not nothing, but uh, okay. So next one, reading. If you read it, okay, that's a little bit more active on your part. Your brain's going to remember a little bit more. Right? If you're writing and taking notes, okay, now again, it's a little bit more active on your part. Right now, your brain's going to remember even more. Right? Like a week from now, you remember more than if you hadn't been taking notes. Right? All the way at the bottom here. Teach others. That's probably the best way to learn anything. I know that's one way I got really good at this class. This was my job in college. I had a part-time job tutoring math and physics. So I'd be handed these questions from left and right field and things that maybe I didn't know how to solve right away and have to look it up and think about it. Right? But then going through that process, now I have to explain it to someone else. Right? That's really, really, really learn this. So the closer you are to applying things yourself, trying something new, being able to get to the answer yourself, teaching others, some of the best ways you can do this. Right? We're going to be doing lots of labs in this class. And so you guys have some lab partners. You guys can help each other out. You're teaching each other, right? And there's kind of a wrong way and the right way to go about the labs. Right? So we'll learn about some physics principles, maybe doing solving some puzzles. Right? Say, okay, well, let's see this out in the real world, right? So I hand you some materials, maybe some pulleys and some string and some weights, and put this together. And now, if you approach the lab sort of, I've seen a lot of students do this, so don't do this. Don't be like, oh, okay, got this lab table. It says put this number in this box. It says multiply this by this and get this and turn it up. You're in the lab point, right? If you kind of have the approach of, just like checking the boxes about it, this number goes here, right? It kind of defeats the purpose of the lab. The purpose of the lab is that you get to see the actual physics play out in front of you. You get to create a small model of the universe. You get to have the kinesthetic application. And of course help each other out. Right? Not sure exactly how to put together or solve something. Like, if you approach a lab with the mindset of like, wait a minute, why are we measuring this thing? Or is this lab table complete? Am I really measuring everything I need to measure? Why would I multiply this number by this number? What does that really mean in a physical sense? Right? They would probably get a lot more out of labs, especially if you're talking to each other, helping each other out. Okay. I got a little tangent story, but let's just one real fast. So this is really a background slide for it's really background, but that is a famous photograph there. Does anybody know what photograph that is? All right. Huh? All right. So that is the edge of the observable universe right there. So story, it's called the Hubble Deep Field. You guys know the Hubble is one of our powerful telescopes. We sent it back in the 1990s. And one astronomer has this bright idea. Why don't we just point this Hubble telescope at a random point in the night sky, just complete blank spot where it looks like there's nothing there. And see what we get. And the small space I'm talking about is like if you pick up a grain of sand from the floor and you held it at arm's length, think about how much space that would take up in the sky. A little tiny, tiny, tiny pinpoint, right? That right there is the amount of space that our night sky does. Okay? So they pointed at a completely black part of the sky. Now, this was a controversial decision to take this picture in the first place. Reason being that to get that picture, you have to open the shutter for like 2 weeks. So they had like 2 weeks they had to open the shutter just to get enough light to create an image at all. They didn't know what they were going to get. I may just get like a black square. So, oh, great, Bob. You have to take a picture of a black square. We could have been using this Hubble to take pictures of like Jupiter and Saturn, all the other fun stuff you want to take. But so they didn't know they got this back. Every single one of these smudges here is a galaxy, hundreds of millions of stars. So this right here. And there are almost certainly galaxies beyond those. Nobody knows how big the universe is. It might be infinitely big, which would have some crazy implications. But because of how the universe expands, any light from galaxies beyond those is just never going to reach us. Okay. Hey, a little tangent story there. But I wanted to throw up a definition in a nutshell. What is physics? So how about this? The study of laws of nature that govern matter and motion in the universe. If you know that fundamentally, how does everything work? Okay? What are the laws of motion? If you drop something or throw something in a gravity field, how exactly does it move? What does that follow? Okay. You have certain weights on a string and certain orientation. Oh, yeah, go. Go. Right. Can you take a complex system and break it apart into fundamental parts? Right? Can you take these fundamental laws and maybe build your own thing out of this? All things you can do. Again, going back to, got the screen right here. Yeah. Got a whole range of students, from students who don't really know what they're doing after high school, the students who have a pretty definitive idea. So we started that into the spectrum. Like what's some definitely direct applications of this class? First of all, anything engineering related, right? If you want to civil engineer, design buildings, how about this building here, right? Or bridges or drainage systems. How about mechanical engineering? Big old machines and factories, right? How about electrical engineering, right? So this class is going to be fundamental to all that. And the things that you learn in this class this year, you're going to be using every day the rest of your life if you go one of those routes, right? Got some rocket science here. Got this guy, he's a Navy nuke. So all the US submarines are nuclear powered. You want to run that nuclear power plant on the submarine, right? Got to know physics, right? Take it through some classes, right? This top picture in the middle, this is kind of a proto fusion plant. And so one of the unsolved problems in society is can you take different isotopes of hydrogen and fuse it together into helium? Well, I actually have done that, but we haven't been able to turn that into a power plant. So the best we can do with that is turn it into a bomb, which is not very helpful for like electricity purposes. Okay? But if we can crack this problem, it's going to solve all sorts of problems in society. So that's what this guy's working on here. So lots of cool opportunities there. How about what if you do have an idea what you want to do and not sure if this class is like super related to it? You might be kind of surprised. So I'm just gonna give you a random example. What if you say, I don't know about all this engineering stuff, but what I really want to do is like art and animation. Like that's my thing. Okay? Well, there's probably a lot from this class you could take. For example, like you put together an animation of like some projectile going through the air, and you stand back and look at it and watch it in motion. It's like something kind of off about it. It's like, it doesn't really click with my brain, and I know there's something off, but it doesn't really work. Then whoever's watching your animation, they kind of subconsciously get that too. It kind of takes them out of it, and it breaks the suspension of disbelief. Okay, but if you know physics principles, you know exactly. Okay, I remember I learned it in class, I learned it in physics. It's exactly how it's going to be horizontally and vertically. And go back. Okay, here's the phrase I have to tweak to make that work. And now it clicks into place. Now whoever's watching it right now they're back in your animation too. Okay. So you never know what the connection is going to be. I got what 30 different students in here. I got 30 different life stories you guys are about to embark upon. You never know exactly what the application is going to be. Kind of extending off that, I've got a specific story. So here I got iPhone, got a Pixar movie. Hey, who started both of those? Who started Apple? Who started Pixar? Who was that? Was that Steve Jobs, probably? Right? So his story, I'm going to say one of the stories. It's relevant to the story. So his family was poor growing up. His parents were really poor, but they always wanted to send him to college. So they scraped together whatever money they could over first 18 years of his life so that like if you graduate high school, he can go to college and they have money for tuition. So he goes to a pretty expensive college. And then while he's there, he realizes he doesn't really know why he's there, what he's doing, kind of what the end goal of this whole story is. Right? So he ends up dropping out of college. He never actually got a college degree, but of course he goes on to found Apple and Pixar and all these great projects, but they never actually had a college degree. Now, interestingly for him in his case, that ended up working out because what they did was it liberated them to go ahead and start dropping in on classes that just looked interesting. What you can do, and if you ever go, if you guys have the opportunity to go to a big four-year university campus, like UCF, UF, USF, some of those lecture halls could see like hundreds of people. I like to do that too, because you can kind of figure out what classes are going on around campus and like, hey, I learned something about astronomy today. Just kind of hop in the back, nobody knows you're there, right? Like wear a sketchy hoodie or something, right? You just like learn lots of cool stuff, right? You do all the time. So Steve Jobs is doing that. Now, of course, he's not getting official credit for these classes, right? But you can learn some. So he dropped in on a class called calligraphy. Guys, what is calligraphy? What is that? Is that? Yeah, writing, like the art of writing, fonts, that sort of thing, right? Right. Now, what possible like practical applications that can have? Right? We have no idea. Probably nothing he's thinking, but it's just they had a calligraphy class. He wanted to learn it, so he dropped in that class and just kind of sitting in the back, all stealth-like. And turns out, many years later, as he and his team are designing the first personal computers, and of course he had the Macintosh and the Apples, one of the thousands of problems they had to crack was, well, how do you create a legible font on a pixelated screen? It may be kind of easy to take for granted now, but what was there before, like the 1970s, 1980 was, it had like typewriters, that kind of clunky font from 1945. But now he's like, and all those principles of calligraphy come back. Right, so the takeaway here being, you never know exactly what you're going to pick up from any class any day that's going to open some door, provide some opportunity that's going to be relevant down the road. So there. Ooh, Google Classroom. All right, so I did post some things over the weekend. They go from bottom to top. Every time I post something new, sends it to the top. So let me look over this with you guys. I think I got a Google Classroom here. Whoops, got to open this up. Google Classroom. All right, let's do. All right, since you guys in front of me are honors, I'm going to pull up honors. My other classes are slightly different, but not too much at this point. Get over here. All right, so let's look, because PowerPoint's, of course, that's a screenshot. But here you go. Here's what I'm having you guys sign up for. All right, so bottom to the top, got syllabus curriculum and the school calendar. Now, those I did print out, so you guys do have those. But if you lose them, you got them here. You can print them out at home. You guys got those. Next one, textbooks. So got a bunch of different books going on. This blue one down here is conceptual physics. That's more for students that aren't super good at math, but actually the book is written really nicely, and I probably will pull some stuff from that book, but more for my conceptual class. The red book, Physics Principles and Problems, that's the main book for honors. So that's the main focus for my honors classes. Pull a bunch of stuff out of that you guys saw. You know what I did not post for this class is the college physics book. That's more towards AP, so not quite there, but there is a digital version of that too. I usually every year have about 2 or 3 students who want a physical copy of the book. So if you do want a physical copy, just let me know later this week. I can get one checked out to you. Usually doesn't work out if I check out like a bunch of them, but you know, if there's a few students, that's all right. Right? Otherwise, you guys got the digital right here, all good to go. Right. I also gave you guys my book right there. So you guys see these posters hanging around the ceiling. Right? Also gave you guys the thumbnail notes when you guys walked in. They're in the plastic sheet. So I've been teaching this class over 10 years. Over the years, I figured out kind of what are the fundamental physics problems. Like, okay, you can solve these, you can kind of solve everything. Anything that I can fit onto a 1-page paper at a time. And that's what these are. Right. So there's about 300 posters here. You guys can download that. You guys got those. Go back to this blue book written by a guy called Paul Hewitt, and also comes with a bunch of physics demos. So there's a couple of zip drives there. I'll play you guys probably a good number of these throughout the class, but there's more that I'm probably going to get to play in class though at limited time. But he's got a bunch of great demos where he'll pull out some equipment, and within 1 or 2 minutes, he'll demonstrate some physics principle. So those are all there for you guys if you like guys like those. Got Colorado University Boulder interactive physics simulations. So there's a bunch of simulations there. Tomorrow, of course, you guys get your laptops. So maybe this will be something you guys can play around with. Okay. For example, I know one of the things they have is cannon blasting cannonballs. It's one of the first things we'll be doing here in a few weeks. Right? So suppose you know the blast speed of a cannon going so fast, and you can change the angle. And so if you have a cannon blast speed, I can change what angle I blast it. Hey, I wonder how far downfield it's going to land. Right? Maybe that could be a calculation you could do. Right? If it would be relevant to some situations, right? Like how far it's going to go. Right? Now, of course, teach you the equations in class. You'll be able to solve that problem a few weeks from now. Right? Attach some numbers to that. But you can open this up and you get the simulation version, right? See an animation. You're like, okay, does that really line up? Right? Okay, so some angle, some blast speed, Earth gravity, put it all together. Oh, hey, look, it landed exactly where the equation said it was going to land. Right, so you guys get that. So I know this first week a little bit choppy. I know we got a laptop week tomorrow and really going on and all kind of stuff. But try to do with you guys is cover some math basics. So algebra, can you solve algebra equations? So basic geometry, circles, triangles. Do you guys maybe possibly remember sine and cosine? You guys do sine and cosine a little bit? Yeah, right. All right, so that's going to be really critically important in this class. It's just like one simple application we're going to use over and over and over again. So that's coming pretty soon. I'll do a review with you guys. Actually, here, I'll give you guys an example. You guys remember I was just talking about blasting the cannon at some angle? Right? So you got a cannon. Let's say you aim it at like 30 degrees above the horizontal, right? Well, that cannonball, even the cannon barrel, it's going kind of across the field at some speed. It's also kind of going up-ish, right? Leaving the cannon. And that's the first thing you have to do is figure out, if I know the total blast speed, how fast across the field, how fast up, right? And that's a cosine and a sine question. So sine and cosine, like right away, we're going to be using that. And then there's more to that problem, but it's like the first step. It's the first step of so many problems. It's called components, called vector components, right? So doing some math cover. Usually any documents we're gonna do, I like to upload like the weekend before. I hand them to you guys. If you need anything, if you're absent, if you lose something, come to this Google Classroom, get whatever you need. There's a device agreement right there, right? So if you check out a laptop, probably you guys have this turned in already. Okay. But if you need it, I forgot to mention this earlier. I got a stack of them right here too. So these laptop forms, boom, right there. It's right there. Okay. So you guys good with Google Classroom? It's on there. Again, tonight, I just want you guys to join that class and then yeah, explore some of those, show you guys what's on there. Maybe download some of those files. Okay. Questions? All right, here's curriculum and syllabus. Got AP, honors, conceptual. So I've got dates, the topics we're going to be learning. Every topic's approximately 2 weeks, some a little faster, some a little slower. Holidays and hurricane days here. And down here at the bottom in this box, there's your Google Classroom code again. So you guys got that. Grading is probably the same as other classes, 90s an A, 80s a B. Got quizzes, labs, and homeworks for you guys, 100 points, 20 points, 20 points. There might be some other type assignments, but those would be the main ones. Right? And yeah, you're doing a lot of those. All right, BPS calendar. All right, let's take last couple minutes here. I got some questions for you guys. How can you measure and quantify your observations? Right? So you do some lab, say string up some weights and some orientation. Hey, maybe I should measure how much weight are we talking about, right? Maybe we should measure what length of string we're talking about, right? Hey, there's a star in the sky. It's really bright. Was it always that bright? Is it that bright yesterday? Is it about to explode? How can I quantify that? You're paddling across the river and the river's flowing downstream. What's your speed and direction motion relative to the shore? What if the river's flowing west to east? You're paddling straight across it, south to north. Ooh, there's some guy sitting in a tree, points a radar gun at you. How fast does that radar gun read? Okay. Or what angle are you going? How many degrees east to north? If you know the speed of a car and the distance to the next town, oh, you guys probably get this one already. I bet most of you guys could already saw this. If you're going 70 miles an hour on I-95, look to the side of the road, you see a road sign, Jacksonville, 140 miles away. You guys figure out how to take about, what, 2 hours to get there, you guys think? All right. All right, so there's your first page of notes, some basic math stuff. I want to go more detail with you guys. I know we only got about 2 minutes of class left here, but first page, all these silver banners are those. All right, next set of questions. Hey, can you feel the speed of a car? Well, let's say your friend's driving and you're in the passenger seat. You're blindfolded. Can you say definitively, yes, we're going 60 miles an hour. You're going 65 miles an hour. Can you feel it? No, I don't think so. You can feel something in a car. It's not speed. Huh. I'll just leave that question out there for you. Ooh, I'll have you guys do this in a few weeks. You drop a ruler, your friend catches it. Do you think maybe the distance the ruler, let's say you catch it at the 19 centimeter mark. Do you think you can back calculate how much time's been falling for, and therefore what is your reaction time? You guys think that ruler is going to fall at a constant speed? You think it's going to be speeding up? What is that relationship? Please get your reaction time. We're going to do this. Blast a cannonball horizontally off a cliff. Go out to the balcony. You got some spring cannons with some bouncy balls. And you get spot, where's the ball land? Okay, so I know what is the height of the cliff, height of the balcony. I spot where does the ball land. I know Earth's gravity field. Okay, can I put that all together and figure out what was the blast speed? There must be some blast speed that corresponds exactly to all those other numbers. All right. Baseball throwing contest. I can throw a baseball the furthest. Well, I can't really change my maximum throwing speed, but I know what I can affect is the angle I throw the ball. Hey, what is that optimal angle to send it the furthest distance? All right, so all these red banners are kinematic motion. Again, I'm going to do more detail with you guys, but this is coming up pretty soon. See if I can get one more set of questions here. Standing in an elevator. Elevator starts to take off. You feel kind of, whoa, the floor is whoa. And then you feel normal for a while. And then when the elevator comes to stop, whoa, feels weird again. What if you're standing on a scale? So we get some numbers. Right? What does that tell you about the motion of the elevator? Suppose you're engineering a truss bridge. So contracting the bridge. Can you figure out what's the tension and compression in each part? So you can figure out what materials to go there. So you can design the strongest bridge at the least cost or something like that. I'd like to do more questions with you guys. See if I can fit in some tomorrow, maybe. I don't know. We'll see. But I'm going to wrap up this recording today. Hope you guys have had a good day. But we're about at the end of class. And then we'll do what we can tomorrow. Of course, tomorrow's laptop day. All right. That is